work on that one computer, bring in all the different cells, and just push that to max. So we can have everything available. But then if you're not comfortable with it, I'm a little bit more comfortable. Yeah, it was practice. I didn't get it fully figured out.
So as we merge everything into
I mean, we could also do the
Nelson, you mind grabbing the door?
Okay, so I pushed all my different branches, and then I was like, okay, I want this from this branch, and this file and this branch. Copied it. I want this piece, and then
we push. Like if there are changes that we want to keep, like if we're just working on one part of the time, like if we're working on a bunch of different aspects.
I just don't. I would want to work in a separate branch first, pull all the pieces in that separate branch while we get them working. I don't want to work on that, and then we would merge it back here.
It's like I'm just worried if we all have a separate branch. Yeah, that's not. That has a bunch of different features. I feel like right now we're all come back together.
Yeah,
I feel like it's starting to we're starting to drift further.
I'm talking about doing it.
If I could weigh in, you're both actually saying the same thing from two different directions.
Yeah, we are.
And you're both right, and it will work. Yes.
I'm just talking about doing it the lazy way. You're talking about like actually properly merging the branches. I was just saying like merge them manually by like copying and pasting. But yeah, we can just merge them manually.
As long as we know what.
I think unless you've done anything that only in index.js, is that the only file you're working in?
And I think I'm not using.
I'm going to get you to table that conversation. I'm going to give you the keywords get cherry pick. That will save you from copying and pasting. And I'm going to get started. So, a lovely good morning to all of you. Good morning, Victoria. As you may have noticed coming in today, Victoria, you didn't notice because your place is normal. Things are a bit chaotic here because we moved a whole bunch of stuff. So we're all joking that somebody came in and stole all our shit last night. But that being said, I've got two things I want to cover today. And I'm going to set some expectations beforehand because this particular lecture is sometimes considered a bit of a brain bender for students. The topic of the day is errors and promises. The bigger way to describe that is other ways to do control flow in your programs. Right now, if we need to do control flow for like error conditions or things like that, if we have an error first callback, we test if error, we console.error it out, we return from that, and that's how we handle it. We're doing a very manual process of doing things. Well, JavaScript actually has a pretty rich error handling system built in, and we can use that. And that's one way to add some control flow to your program that happens automatically. And Then the next level from that is a lot of times if you're dealing with asynchronous operations, that error handling doesn't really solve your problems. So you need ways to be able to deal with asynchronous error handling. And that's where promises come in. So I'm going to cover each one of these, and I will go as deep as you push me to go. Otherwise, I'm going to keep it at a relatively medium level, for the simple fact that both of these techniques, when you first look at them, you're like, well, why would I do that? What I do right now works just fine. And it does. I want to be super clear. The way that you handle errors right now works. But there are other ways to add control flow to your programs, and these patterns will come up a lot, and you'll probably find that as you as a developer start to mature in the way that you write code, you're going to want these patterns. Yeah, I'll go as deep as you guys want me to go down these rabbit holes, but I'll show you the basics and then let you just let it kind of soak in and marinate. So I want to start off talking about errors. So I've just got a new file here, and what I'm going to say, I'm going to make, let's make a function add, and I'm going to test if x plus y is equal or is not equal to 4. Let's do that, nice and easy. We're going to create an error, just error as normal in JavaScript. And by nature, that will be undefined. But in this case, if x plus y is not equal to 4, we're going to generate just an arbitrary error condition and say that error is, something like this. And then we will, well, let's do it with a very typical callback. We'll do the callback with error and x plus y. So there we go. Now we can use this by calling add to, and, well, let's do it as fat arrow. Result, console.log, result. So theoretically, 2 plus 2 is 4. We should not get an error condition, and this should just log out. So let's watch this run. And we get back undefined. Awesome. Which was totally not what I wanted. Why did that do that? Oh, I know why. That's why. We get 4. Yay, it works. But we're not testing for our error condition at this point. So we have to make our code a bit more robust because not testing for our error is, as a developer, kind of criminal. If you have an error that is being passed to you, if you have access from whatever library, from whatever function, callback, etc., if you have access to an error object, it is your responsibility as a dev to test for it. That's just responsible coding, because otherwise an error could happen and it would blow right by and you would never know why your program didn't work the way you expected. So if error has a valid value in it, we will console.error out. We will return false. And let's just add a little bit more of a success message here. It's a bit more of a success message. And now when we run this, we get 4. Perfect. So let's change it up so that it no longer equals 4 and see what happens. Now we get error. So this is a good thing because this means that we are now able to, in our business logic, create an error condition for when data comes through our app in a way that we know doesn't work. Doesn't matter what that condition is. It could be, we're pulling from the Brewery DB API and we're not going to display any stouts because we never liked stouts, so we're not going to show it to anybody else anyway. So if the beer that comes through as we're downloading beers is a stout, error condition is it just gets kicked out. We can define these things as developers. We can define what the conditions for write data are inside of our application. That actually gives us a tremendous amount of power. Now, the way we've done it here is what we would call the naive implementation, in that all we have done is created an arbitrary message and looked for something that wasn't false. So if we want to dive just a little bit deeper in and look at what JavaScript gives us for being able to work with errors, then we get to take advantage of the error object itself. And now in doing that, now we get a proper JavaScript error. We've seen these all over the place. Okay, I'm sure you guys have never had an error yet in your code, but just in case one comes up in the next few days, this is what it looks like. But this gives us the full stack trace that takes us all the way back to inventing the universe so that we could run JavaScript so that we could get this particular error at this point. But it's actually reporting, hey, there was this error. And this is one way now that we can represent this error, which has just given us a little bit more refinement than, oh, hey, here's just a string that we threw in there. So it'll actually tell us, for example, line 4, character 11, this is where that error occurred. And if I go to line 4, in character 11, oh, there's new error. Okay, great. I can see that. I see exactly where the problem is. X plus Y did not equal 4. That's great. So this is one way. Now I'm going to take this one and do something slightly different with it. I'm just going to say error equals true. And down here, instead of doing console.error, I'm going to say throw new error. We'll just give it an arbitrary string. And now we have a very different behavior. I mean, this part down here is still the same. We're still getting the error output. But here, it's now telling us in this script on line 15, execution stopped at exactly this character. Because this keyword throw literally gets its name. I wish I could make this up. I wish this was, some fantasy story that I was just telling you. You ever heard the phrase throw a spanner in the works? Meaning like throw a wrench in the gears? That's when we throw an error, we want to stop the machinery. That's where it gets its name. So if new error, we know what that does. That creates a new error object. We just did that. So if we throw that new error, then we have the ability to halt the execution of our code from wherever it might be. We could be 40 callbacks deep. We could be 16 module requires down some dependency chain. At the moment where we throw an error, we halt our application. And that might be the desirable behavior you want, is to actually have your app crash in some situation. Like, let's say you tried to divide by 0. Well, instead of letting the universe implode, we'll just throw an error and stop. So we now are a little bit more in control of our execution because we have the ability to create this new error. But let's take it one step further. now I can generate new error objects. I can actually throw those error objects and halt my program. But maybe I don't want my program to crash every single time. Maybe I want to provide kind of a graceful fallback for my program. So that's where I enter into this wonderful world of what is called try catch. And try catch is just 2 blocks. It is literally the error equivalent of an if else. And literally what we are saying is, if this code works, great, do it. If it doesn't, if it generates an error, especially an error that gets thrown, catch it. The else, catch it. We're able to bring in that error object so that theoretically we could grab information from the error object. And we can provide a graceful fallback behavior. And I just want to show that execution will continue after that. That's why I'm doing that. So there's my nice graceful catch happening. I'm able to provide a less jarring experience for my user. I still have an error condition that occurred. This might be a case where in my catch I can log it out to some log file, send an email to an admin, send off an AJAX request, like something to say, hey, this broke, but I now have the ability to allow my program to continue executing even though some error condition happened. Think about, for example, a user trying to upload their avatar. And you've probably run into this before with one site or another where you pick the perfect image that you scoured your hard drive for in Google Images for like an hour, and you upload it, and it's like, this image is too small, or this image is too big, or this image is in the wrong format. Well, that's an error type condition, and we can now build the proper handling for that. Yes, we could totally just have something that says if it is too big, then send this message. Or we could, test the size, and if it's too big, throw an error. And then the catch for that is to send back a response that has this particular message in it. So we're now able, really the key piece here is that we're starting to build execution flow into the logic of our application as opposed to using the business logic as our execution flow. And it's just this slight change in how we think about it, where we're now using the programming language to, believe it or not, control the execution and separating execution flow from business logic flow. It's actually 2 separate efforts of code in our apps that we're writing. And it becomes kind of a really powerful thing when you start to separate those efforts, because there will be times, and you'll see this with your midterm projects, that there'll be times when you go to do something, like let's say you're doing the food ordering and you go to send an API request to Twilio, and Twilio just doesn't answer for whatever reason. How do you handle that? Like, do you just stop the program? Does it just hang and wait forever? Well, no, now you can actually handle that a different way. And so errors give us the ability to do that. And if we really want to, this becomes now the more mature way, or the most mature way to handle this, where we actually generate the error object up where we detect the error. We send that error object to the right part of the business logic. Business logic checks to see if the error exists, and if it does, it just throws it. And then the try catch will allow that to happen. And so in this case, it doesn't even matter. Like we've ignored what the error message originally was, which was, this, oh my God, what's this for? But we could also always, we could do e.stack. I think it's e.message. We'll find out in just a sec. Yeah, there we go. So I can display my error message by grabbing it from the error object. That error object, when it is thrown, is passed to catch. And as a convention, what you will see a lot is just catch E. Why E? Because E is short for error and E is easy to write. It could be error. It could be shit that broke. Like, you can name it whatever you want. But the convention you're going to see quite a lot is just catch E. And we actually grabbed that from Java. That's one of the things. Try catch is actually a construct from Java that we pretty much yanked right into JavaScript. So this is present, and it's something that I urge you to experiment with. Maybe not this week with your midterms, unless you're feeling pretty comfortable with it. But it's something that you can start to build in as especially if you're doing like little one-off scripts for certain things. Give yourself the opportunity to throw a new error, because that starts to get the idea that when an error condition occurs, you're using the right object to handle it. Any questions about that? Yes. So my business logic is ultimately, when I call add, I'm going to be calling a callback method and passing two things to it. That ultimately is my business logic. I'm going to add things together, and I will get an error object and the result of my addition. So here, the try catch is my execution flow. It is me saying, try to do this action, and as long as it doesn't generate an error, consider it successful and carry on. And the other option is to catch any errors that are generated by doing that code. So in the course of doing my business logic, if an error pops up, my execution flow logic will handle that. Right, it very tightly couples at that point. And yes, as part of my business logic, I'm going to test to see if the error, like when I ran that in my callback function, did that error happen? And if it did, just throw it. Like, I don't have to care what that error is or why it was generated. If I detect the error, I'm just going to throw it and I'm done. And I can even abstract this out a bit. Let's make a function callback that gets an error and a result. And here, if I can remember how to use my editor, I'll do that. So now I'm separating things out even further. And if I want to clean this up just a bit. And here's a case where I really don't need the curly braces, because the throw is automatically going to halt everything at that point. So now, this is me refactoring this down, and it's, it's a lot cleaner now. And that's the kind of thing that I'm going to want to look at, because now things are way more manageable, compartmentalized, modularized. I can see all the parts. And just going back for demonstration purposes, if I change it back to the working condition, all we're going to see is success, and now the program is done. Because no error was generated, no error was thrown, so there was never a need to output the message or the, hey, have you tried adding 2 and 2? It just works the way you would want it to work. 100%. Yeah. So for Victoria's benefit, what she was just saying was, now that we've modularized even further, now we have reusable logic that we could put into different places, like this callback. It's going to check for the error handling. It's going to console.log out as successful. Whatever it may be given, we can use that callback anywhere. So it's now way more reusable. Have you guys been introduced to the first principle yet? No? I get glassy eyes, so I know that's a no. Let me introduce you to the first principle. First is a principle that we use when we are refactoring code, when we are looking at when you're about to break things into modules for your Node app, when you're refactoring things down as functions and stuff like that. First is generally the principle that we use for this, and first stands for fast, independent, reusable, safe, and testable. So fast, meaning that basically each function has one job and it's not going to take too long to do it, or each module, you're not unnecessarily double looping over data for no apparent reason. You're not reading 500 megs of stuff from the file system if you can possibly help it. You're using stuff, you're caching, you're trying to be smart in how that business logic works. Independent means that theoretically each module should be able to be picked up and used in a different application if you needed to. As much as possible, you don't want it to have to be tightly connected to anything. Reusable means not only are there less dependencies, but the functionality that you've broken out is functionality that you're likely going to use in multiple points in your app. You're not just refactoring it down for a single use. It now becomes something that either can be used other places in this app or could be used as an entire module in another app. Safe is that the module is safe to use, meaning it doesn't have side effects, arbitrarily destructive behaviors, unless that's the point of the module, is to like delete files or clean out databases or something like that. But that if you were to pick this up and move it to another application, it's not going to jeopardize the data integrity in that application. And then the last one is testable. Can you write tests against this module and prove that it's doing what it's supposed to do? And again, that's trying to reduce things like side effects and stuff like that. But this first principle is one that will affect the way that you build modules, and also even the way that you handle stuff like errors, because errors in a lot of ways, the logic around handling an error really should follow this principle. The error handling logic should be independent, for example, of the business logic. The error handling ideally is kind of reusable. Safe, meaning that it doesn't kill your application, and testable, meaning that if you generate an error condition, you should be able to test that it does what you expect it to do. And errors are always fast because they cut through everything else. But yeah, first is a principle for something like that. So this is a good example of, pretty much anytime we build ourselves a function that has a callback being passed to it, we're now making it more independent. We're now speeding things up just a little bit. We're making it more reusable because now we can pass any arbitrary callback to it that we want. And now this callback function that we have, oh gosh, we could use that anywhere for anything. So yeah, this is starting to head in that right direction. Any questions about how I got here? Victoria's nice and quiet, so I'm going to assume they're okay. Right?
But regarding the if-else for errors,
yes.
What does it mean if you handle an error, but you still get an uncaught error issue?
That's okay. So the question there is, when using if-else for handling errors, what happens if you have written code to handle the error, but you still end up with some kind of uncaught exception? I promise the answer I'm going to give you is not going to be meant as snarky as it's going to come out. It means you need to write better code. It
The error handling needs to be better, or something else?
Typically something else needs to be better. The reason I say that is because if you have built in even remotely adequate, like basic if-else, error handling, and your program's still stopping because of some uncaught error, then that means that there's something else in either logic or syntax that you haven't accounted for that is above and beyond the logic that you have tried to put in place. And that's just a case of like, it's not. The reason I gave the disclaimer about snarkiness is it's not to say that you didn't write good code in the first place. It's that there's something in your code that was out of scope in your brain and you have to go track it down. Everybody deals with it. It's bug fixing, it's refactoring, it's that kind of stuff. But that is the flag that pops up that says, oh crap, I've got to go fix my code somewhere else. Cool. Okay, it's 9:30, almost 9:35. Let's go ahead and take a break now, because this gives a good divide between this and promises. And then take a 15-minute break, because that way we can stretch it out a little bit. Yeah, promises should only take about a half hour to show. So, yeah.
At first, I couldn't see all of the files in BitBranch. I can't see any.
Those two? I pushed them at the end of the late, right
Yeah.
after we. After jazz.
Yeah, it should be just. So I can see. I can't.
Yeah.
Yeah. So his other file. Every single thing before this.
Since the lecture started.
When my computer. I.
Yeah, what the actual error is. Something else is about error. I mean, it's like, as in, okay. For all that, it could be, if divs. That role, like, it's generated. Yeah, it could be a variety of errors. So it's trying to insert the column however long. None of this. You're just setting it up. It's just bootstrap there.
Okay, so like when you call it,
Because
what I was
this
doing
one
this morning, like
without catches.
have you have the
Yeah.
query logic right now, and you have the backend stuff right now, and you're running stuff, if you can
Yeah,
merge
so
those
that's
today,
no, but
you
so
guys
as
can
far
help
as
me
the
get
other
that
companies,
working. That'll give us like a good test space. Rolling up.
This will be
Oh yeah, okay. You need
at
to
least like
call
we get
the,
database.
but you also need to do
When you actually do insert and
And then
you gotta do the callback part.
post on it.
Yeah, it'll just give us something to test.
Callback is what you want.
But
Yeah, yeah,
also,
which
I really think we should
Yeah, yeah, so
stay on
the
getting
callback
the
is what
API.
you want.
then
'Cause that's
and
gonna be
for example, yesterday the
Don said,
call
what I
back
heard this morning.
Yeah, so, yeah, so when you want to use callback function, whatever you want.
Sending the text is easy.
actually
I
he
don't know
Same
how
for
it
get
will
users.
he showed me a way in object kind of
That's the way it is.
it's he showed me actually way of actually switch going out.
When you
That's like what page are you on?
This is just Flash actually.
Oh, okay. Yeah, I would just exit it and like restart.
I already tried
Yeah, there is like a
this or do that?
You don't need
We're sending
to create a generic, almost like a
regardless.
framework.
Whenever we have
Create new object and then say this object based on user table. Yeah, you still have the same. You don't have to.
Let's make sure that
the
we
same.
have
So
control.
almost the same for every table. Wouldn't have to take the message.
Yeah.
I don't want. Maybe I can go back and refactor later, but
we'll have to have.
So that, it's like, and like that to really like.
We're also gonna have, but to handle like what he said, if
I think
well, it's going back to what Jeremy always put an end or put an end. But it's an error catch.
see people.
Oh no. Looks like it's down, but I mean,
Weren't having any problems.
Oh,
The
okay.
JavaScript files that come with Bootstrap.
It's like pulled down.
Oh, like you installed Bootstrap, okay.
Every how
Okay.
If you. Yeah, so like, yeah.
Oh, that's
I hadn't installed it, I was using off the
Yeah,
website,
yeah.
and it was like screwing up all of my.
Yeah.
So I'll
Because it
try
also
that.
uses jQuery, like itself.
I'm wondering if we.
I wanted to get
I know it is our jQuery.
Yeah, but the one that
Yeah,
I
but,
saw on the
like, eventually
website was
I'll
the
ask.
minimized
Yeah,
version,
yes.
so the jQuery.
You might as well.
Or no,
do it.
Slim, it was the.
Yeah, so you're just using the.
Yeah, if you do have to buy a new one, next week.
That's not
Yeah.
used.
That
Things you can use.
like I have in my
the grid,
PC
you
at
can use
home,
the
so I
grid
can
properties.
read this stuff. This is and toward
No wonder. I was trying to find.
Yeah, I don't
I
think
find
it's
something
bad.
else in there, but I can't find it.
Does it feel differently?
I didn't
It
touch
is
the
still
keyboard. I
hard.
was looking at it.
Oh, it's okay.
The
It's
screen
like
looks very
always in
similar.
Pro.
Really?
Right? I mean, so
Do something.
yeah. Okay, but
Also,
anyway.
it's lag.
I'm not a Mac
Side
person
person.
either.
Thanks, Delphin.
Still need to.
No,
I
it's
think
okay.
just asking about.
Oh.
Okay. No, that was.
I was. Yeah, so I basically pulled the bit. Yeah, so without.
Oh, I committed but didn't.
Yeah.
Yeah, the last man.
Um, um, I mine is in. I was just
Oh, no, no.
yeah, this is a different branch. This script right here.
I'm about to jump back in, guys. Okay. So, second piece of the puzzle today for dealing with program flow, execution flow, is what we call promises. Now, errors that we were just working with are very much synchronous. They occur in series where you tell them to occur. They're very, very synchronous. Promises are one technique that you can use for handling execution flow with asynchronous events. And I want to give the example of a personal check. So, from a conceptual point of view, let's say that I'm going to write Raph a check. He'd probably really appreciate that. No problem. It's about 27 cents. It's totally good. Won't bounce at all. Boing, boing, boing. But when I write a check to someone, whether it's RAF or BC Hydro or whoever it may happen to be, this is what we call in the financial world a promissory note. This is a piece of paper that says, I promise that when you go to the financial institution, then you will get money. And this check, when it is presented, when that promise is to be collected, will either resolve the promise by giving me money, or you will get rejected. That language, that concept is identical. It is parallel to how the code construct of a promise works. A promise is something that we wrap around an asynchronous function. We're making a connects query. We're making an AJAX call. We are using Node's request module to request something from an external API. We're waiting for a big file to write to disk. These are all actions which Node will handle asynchronously. Now, we don't know when those are going to be resolved. If I hand Raph this check for 27 cents, I don't know if he's going to be like, woohoo, I'm rich, and go running out the door across the street to TD right now, or if he's going to stick it in his bag and find it next week and go cash it then. I have no idea. But the principle behind it is that when he does, he will either be able to resolve this promise or reject this or get rejected from this promise. And if you cash it next week, I'll get paid. So in code, I wrap a promise around an asynchronous action. And what I'm saying is, I promise to do something. I will register a callback that will happen when this asynchronous action ends. So the promise is literally in code saying, I promise when this function ends, I will do this if it works, and I will do this if it fails. And that's super helpful, incredibly helpful from a code perspective. And so to show you that, I want to use connects, and I'm actually going to use the same connect stuff that we did on Tuesday with the hockey database. Because A, I've already got the connects file set up for it, but B, connects is actually primarily promise-based. The .as callback that we use is our way of just doing it as a typical vanilla callback, but I want to show you how promises can work with this so that you see a different way. So what I'm going to do is I'm going to nuke this index.js file. So I'll require in my connects file. Okay, so now I have connect set up, and so now I can actually run a query. And so let's start off with something nice and easy. I'm just going to select star from Teams. So before, what we would have done is we would have done as callback, and we would have had Teams, and we would have then done stuff with them. Well, I'm just going to change the language slightly, and I'm going to say .then. Do the query, then do this. And that's it. Whatever I was doing as callback before, now I'm doing .then. And this will work unless I forget to do the other thing, which is make sure that I actually have something in my node env. Oh, really? Fine. Wow. Not my day. If you're going to query Postgres, make sure Postgres is running. I know how to code. It happens to the best of us. Like, oh gosh. Ta-da! So now it works. And that's the same behavior I would have had I done that with as callback. Where things get powerful is if I now do .catch. So the same term that we used in try catch is how we also register a rejection situation with a promise. And there we go. So now I'm catching that error. So .then allows me to keep the program flow going. And what I'm literally saying is run this query, and when it comes back with data, then do this function. And that's really what we're saying all the time with as callback. We're saying run this query, and here's the callback that you will use for handling the data once the query comes back. Exactly the same. I just am registering it in a slightly different way. I'm taking advantage of the promise. All promises must either resolve or reject. Otherwise, from a code perspective, it's like a sneeze that you just can't quite get out. And you will actually get an error when your program ends about unhandled promises. Because promises actually have 3 possible states: pending, resolved, rejected. So if a program ends with a promise left in a pending state, when the program ends, the garbage collection is going to clean up all the stuff in memory, and if it finds a promise in a pending state, it will complain. That's a bad thing to do, because it means that you have some action that your code was supposed to do that never ended, or you never handled. But the cool thing here is we can actually now take this a bit further. So let's say I do this, and now I can do this. And I might have a bazillion lines of business logic here. But at some point, when I need that data, I can do this. And it still works. In fact, let's do this. And I'll probably need to do this. There we go. 1, 2, 3, 4, 5. Ta-da. So once I understand that I'm working with promises, I can trigger the asynchronous action. And then at any point, I can register the .then for handling that. And that promise will just sit the whole 5 seconds. It was just sitting there pending, just waiting in memory for something to be registered to resolve it. And then if I actually do something like don't have my, well, this may or may not. Let's see if this works. I should get the WTF, I hope. Yes. There's my WTF. So that's my catch actually working. That's me providing that graceful fallback behavior for if the promise were to reject. Because the promise went off and it said, well, hey, I tried to do my work, but I got rejected. So there's my handler for dealing with that. I can also have as many .thens as I want, as long as each callback function returns a new promise. So I can make promises. And let's launch Postgres again. So I can make promises where what I can do is, I'm going to get Teams here. And I'm going to return new promise. And a promise wraps around a function. And by default, that function gets 2 parameters, which are resolve and reject. Those are references to functions I can now call to manually resolve or manually reject that promise. There we go. And now what I can do is .then aha. There we go. Totally contrived. But basically, my promise is I will return a new map. You know, so I'll go through and I'll process all the data I got from the database, and I'll build the names of the cities so that it's city name, team name, and I'll just return a new array from that. And whatever I return becomes the parameter being passed into the next .then. Absolutely, everything just gets passed down the chain as long as you keep returning promises. Well, actually, I don't. Oh, I lied. This actually gets a lot easier. .then, if you keep chaining .thens, will automatically return promises. So all I have to do to keep this going is just return the map, and that will automatically feed into data. And then if I return something else, I could feed it into another .then. I could have 500 .thens. And that allows me to actually have a whole series of asynchronous actions and now effectively schedule them so that they occur in the right order. This is way cleaner than having callback, 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 callback. Even if you break them out into functions and you're trying to trace that execution, I would much rather just look down a file and see .then, 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 because If we don't make any references to dude, where's my car, it allows me to say this is going to happen, and then this is going to happen, and then this is going to happen, and then this is going to happen. And each one represents an entire unit of work. That could be, 100 lines of code that are going to happen before it moves on to the next action. But helps if I code correctly. Yes, that's what I want. Really? That's console.log, that's that. Oh. There we go. Four, 5. Woohoo! Oh, there we go. So I just have to find out why I did that. Oh, I see why. The return value of yeah. Suddenly 5 seconds gets long. So there we go. Yeah. So this is a different way for me to handle control flow. And it becomes a really powerful way for me to handle control flow anytime I'm dealing with asynchronous actions. Database queries, in fact, most JavaScript database libraries now, Connects, SQLize, Massive, Waterfall, which is the ORM in Sales.js, like most of these now are promise-based, so that you run a query, then with the results, catch with an error if it happens. And it becomes such a good pattern. What I would encourage you is if you find that this is clean and you like the way this looks, start working with it just with pre-built libraries that are already promise-based, because it will help you to order the sequence of events that are going to occur with your data. Once you are comfortable with how this works in, say, something like Connects, then you can evolve what you're doing to start building your own promises. Because when you start building your own promises, then you are now once again in that situation where you are building the execution flow and the business logic flow, and you want to make sure those are handled correctly. Get comfortable with just how a pre-built library can work with your business logic, and do stuff like this with queries, because once you're comfortable with this flow, starting to do it on your own becomes way more possible. A lot of people will start trying to dig in and write their own promises inside of queries, and promise within a promise and multiple resolutions or multiple rejections, and it just gets ugly. Instead, it's way better to substitute as callback for .then, and even be able to continue working with data after that. Then evolve yourself to that next stage where you start writing your own promises and figuring out how to manage that control flow yourself. Questions about this so far? Yeah.
The first one is relatively minor. I just noticed that in the first then.
Correct.
Return. Is that just because?
So yeah, with the absence of a return here on line 10, this is an ES6 thing with fat arrow functions. If the body of your function is a single execution, it automatically returns that. The other thing is if I don't put curly braces around it, if I don't build a block, then it will automatically return that. If I build a block, I have to manually return. Yeah, so that's an ES6 thing.
Okay, and then the second one was I got a little bit confused.
Oh yeah, I added something and I shouldn't have. I made it more complicated. And so I reduced complexity by taking that out. Yeah, the thing is, the same way that we created new error objects, you can create new promises. And when you start building your own modules for things, you can totally do that. And that way you call a method from one of your modules, it returns a promise, and then you can just .then from there, which is great once you understand how that works.
But that would be so
Not quite. So the new promise contains a function. That function would be where the asynchronous action is. And then inside that function, I would call either resolve or reject based on the outcome of the asynchronous action. Resolve would take whatever I put into resolve and send it to .then. Reject would take whatever was there and send it to .catch.
so
Yeah. And that's the other nice thing, is it automatically cascades through the .thens as long as each thing returns a positive result. If any of these .thens threw an error, it would automatically go to .catch and skip all the other .thens. .catch is just like the catch in try-catch, which is why I showed that first. As soon as an error happens at any point, there are the .catch gets triggered and the error object gets passed. Okay, so with promises, I also have a couple other things that I can do. And I brought up the MDN documentation so that we could talk about it from there. Yeah, here's the 3 states: pending, fulfilled, rejected. I tend to say resolved instead of fulfilled, but it means the same thing. The methods on promise, it actually has very few methods. There are only 4 of them. Resolve and reject do what you would expect. If you do promise.resolve, that returns a promise object that is resolved with the value. So you could do promise.resolve value.then callback function, and that would handle that. Promise.reject, similarly, you can handle from there. The other 2, promise.all and promise.race. Of these 2, promise.all is the one that you will be most likely to use of those 2. And what promise.all does is it takes an array as its parameter, hence the term iterable. It takes an array as its parameter, and each thing in the array is going to be some asynchronous promise-based action. Like, I could make an array of connects queries. So let's say I did promise.all connects teams, connects players, connects coaches. So here we go. I've done promise.all, and I've passed it this array of 3 different queries. Promise.all is not going to resolve until all of the asynchronous actions have finished. If any of the asynchronous actions throw an error, it goes to .catch. But if all of them succeed, it will aggregate the return values of all of them into one thing and pass it to .then. So what I'm able to do now is all the queries .then data.forEach thing console.log thing and .catch error console.error error. So now when I run this, what it's going to do is it's going to go and run all 3 of those queries, And all of them, you notice, do not have a .then or a .as callback on them. So they're just going to be in that pending state. But they'll run and they'll return their data, and basically internally they will signal to promise.all that, hey, each one of us is done. That's when stuff gets passed to .then. So let's actually watch this happen. I'll comment this stuff out. And I get an error. Oh, I deleted the coaches table. Oops. Oh, good. I have the migrations. There we go. So a ton of data here, but there we go. Nope. So yeah, I ran that migration. Now we get so we get an array here that is all of the teams, and we get an array that is going to be all of the players, and it's showing me 100 of them, and there's 788 more items, and then we get an array that is all of the coaches. We don't have any coaches in the table because I just made the table. So that's what we get. So this is now one big return that was literally, it was an array of 3 arrays because each one returned multiple rows. So I get an array of 3 arrays, and each one of those arrays I then logged out. And so if I wanted to make that a little bit more visible, what I would do is thing.length. There we go. So the other cool part about this is, why would I want to do this? So let's say I've got, let's say I'm migrating some data from one database to another. And so I've got a couple database connections that I'm doing. And I want to take all of the data from this database. I want to read it in. I want to do a whole bunch of stuff to it. Then I want to put it into some other database. So I could schedule all of these things as a .all, wait for them all to finish, and then just report on the results. That's a nice thing. That's a really nice thing. Or I can have, say, a bunch of API requests, like, I don't know, let's say I was doing, work with me here, a smart to-do list. I know you guys would never have that as an option, but and I wanted to figure out when someone passed in the word Hannibal, whether they were talking about the Roman leader, whether they were talking about the book Hannibal or the movie Hannibal. I don't know. So maybe I'm going to go query Wikipedia, I'm going to go query Amazon, and I'm going to go query IMDb. I want to get all the results of that back. I don't want to have to do this one, check it, then do the next one, if else. I just want to fire off 3 queries, get back a bunch of data, and then decide what to do based on the data I get back. So request to Wikipedia, request to Amazon, request to IMDb, wrap it all into promise.all, and when it comes back, .then, deal with the data. Useful, very useful. So then that brings us to the other one, which is promise.race. Now, promise.race, I will say that in the 4 to 5 years that promises have been around, I have only ever found one good use for doing promise.race. We actually used it in the 21-day challenge that we released earlier this year. And all credit goes to Joel. He figured out that we had a use case for promise.race, and I didn't see it at all. So all credit goes to him. But the situation we were in is what happens if somebody put in code in the 21-day challenge that was an infinite loop? What do? So we actually set up a promise.race that had two things in it. One was the running of their code. The other was a timer for 5 seconds. If whichever one finished first would determine the outcome of that testing of the code. If the 5-second timer finished first, their code took too long to run, and we would tell them that. If their code finished first, fantastic, we use the results of that to determine whether or not they passed the challenge. So that was our use case for using promise.race, and it's the only time I've ever seen a good use case for it. But you could use it for other timeout situations, like let's say you are loading a file from disk. You could have a couple second timer, and if it's taking longer than that to load the file, then you're just going to give them an error saying the file's too large. That's one way to handle it. Another case for promise.race that I've heard is basically you're going, so the situation is similar to like a 21-day challenge or some kind of code battle, is you have two people going against each other, and you take both of their submissions, you put it into a promise.race, and whoever's finishes first is the one that wins. That's an idea. You will probably never have to worry about promise.race for years. And it sounds like this really cool tool and that you try and find a use case for it. Don't. It's really finicky, and it's all about the timing of things. So yeah, it's very rarely used. Like I said, I found one use case for it in 5 years. But promise.all, that one is actually pretty useful for working with. But yeah, resolve and reject would just manually resolve or manually reject the promise based on what you were doing. There is a ton of good tutorials and videos out there. If you look up on YouTube videos about promises, just seeing them work is usually one of the best ways to kind of lock it in. But like I said, one of the things you really want to do is just use the pre-existing promise-based libraries and get comfortable with how that workflow works. The last thing I want to talk about when it comes to promises is there's .then and .catch. There is also a .finally. And .finally does have some uses, though you won't use it often. .finally is to register a callback which will run regardless of whether the promise was resolved or rejected. So literally, you've got promise, .then, .catch, .finally, and the .finally will be a callback function that you would want to have run regardless of what the outcome of the promise was. Maybe you just want to log out like made query to IMDb, here are the results. So yeah, that is there, but you won't have to use it very often unless your business logic calls for it, but I wanted to show you that it was there. .finally will run, the handler is called when the promise is settled, whether it's fulfilled or rejected. And the language is nice. .finally, do this. This also takes you through some good examples of how you can build promises and what it looks like. Ultimately, at the end of the day, this is very similar to how jQuery's Ajax works. They use a special, they have some special logic around their promises, but you can literally do, $.ajax, blah, 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 .then, and have a .catch as the success and the error functions. So that's kind of peeling back that curtain a little bit. But jQuery's Ajax is promise-based. Promises work both on the front end and the back end, so they'll work in client-side code as well, which is really nice. Here's an example of a promise. So my first promise equals new promise. The callback function here has resolve and reject, and we're going to call a set timeout, and we will manually call the resolve function and say success. And that'll be after 250 milliseconds. And then we get to say my first promise .then and we pass that success message. So this string here of success goes into success message, and we will log out console.log yay plus success message. So we'll get yay success after 250 milliseconds, or however long the timer is set for. And if we did reject, then whatever we put into reject would be the error that goes into .catch. Make sense? Clear as mud? Yeah. Like I said, read through this stuff, worry about it more next week and the week after when you start doing a little bit more advanced things with JavaScript. For now, focus on how .then and .catch can help you with connects queries. That's the key thing that will start getting you comfortable with that workflow. But just understand, like I said, my example of this check. Yeah, when Raf takes my 27-cent check to the bank, then he gets 27 cents, or he gets told Don's broke ass. So that's something where you, whatever is running that asynchronous action theoretically would have a timeout, which in this case would probably be Raf flipping a table. That would be the error handler there.
What is the difference? How is that different?
.race is handling multiple promises at the same time. Yeah. Promise.all and promise.race both take multiple promises at the same time. Promise.all is waiting for all of them to finish. Promise.race is waiting for the first one of that list to finish.
Okay.
Yeah. Yeah. Cool. I knew we'd finish early because it's hard to go too deep into this without melting your brains. So I will give you back 7 minutes of your life, and if you do get stuck on any of this stuff, feel free to come by my office, and I'm always happy to talk about it. Cool. Thanks, guys.